This is one of those classic AP Calc questions where they're asking us to determine which of the following must be true, which is their awesome way of basically saying, here's 5 little problems down below and figure out which one of those little ones answers the bigger question here. So let's see what they've given us information-wise. So they're telling us that we have this equation, y equals f of x, which is twice differentiable. All they're really telling you when you see things like that is the derivative is okay to do twice. So you're allowed to have a second derivative if that's helpful. Then the next thing they tell us is that we've got this other equation here, r of x, that is the tangent line to the graph at x equals 3. So based upon that information, and then also on the fact that the tangent line is always greater than the actual graph. So that's what that's saying there. When they say r of x is greater than or equal to f of x, they're telling us that our tangent line is always above our actual graph. That's kind of the important piece of this problem. So based upon that, let's see what we can find as we start coming through here. So answer A here is saying to us, f of 3 is greater than or equal to 0. Well, when I'm talking about the f, the original function, what they're saying is that the y values have to be greater than or equal to 0. Well, that could be true, but there's nothing about this problem that says that it must be true. For all we know, this entire f of x graph could be down here going like this in the negative space all day long. And we could definitely have a derivative at 3 that is above it in that space there. So there's nothing about that that makes us say that that must be true. Could it be true? Sure. But remember, when you're doing this, it is a must be true situation. So we'll cancel that out because it could be negative for all we know. Then we go on to B here, which is saying the derivative at 3 is greater than 0. So when we're talking about derivatives, derivatives are about slope. So when we have a positive slope, it's basically saying at x equals 3, the graph is increasing. Well, again, could that be true? Sure. We just taught, if you look at this example I just drew, that could be where 3 is happening. But there's nothing about this. If all that we know is that our tangent line has to be above our actual graph, for all we know, it could be above it on a section like this. And so that would be in a decreasing section. So could B be true? Sure. Is it a must be true? Absolutely not. And so therefore we throw that away. Looking at C, C is now saying to us that our second derivative at 3 is less than 0. And so second derivative is telling us about concavity. A negative second derivative is telling us that our graph has to be concave down like a frown. Well, if we look at that shape right there and draw tangent lines, we can see that everywhere I would draw a tangent line on this shape, no matter what, these blue lines, which are my r of x graph, are above those purple lines, which would be my f of x graph. So that is absolutely 100% true and must be true always. So what we know is C is absolutely 100% true. There's no way we could have drawn our graph with r of x always above f of x if this graph wasn't always concave down. Looking through the rest of these, kind of trying to see why the rest of these aren't right, is our derivative less than 0. So f prime of 3 is less than or equal to 0. Well, again, could that be true? It's telling us that the derivative is less than 0, so that means that our graph would be decreasing. And, the same sort of example graph that I showed up above, like we could have had the graph be increasing for all we know. And so there's nothing that says that it absolutely has to be decreasing. And so that's not true. And then if we looked at this last piece at E right here and said, okay, this is saying that our second derivative at 3 is greater than or equal to 0. So second derivative is about concavity. A positive second derivative tells us that this graph would have to be concave up. Well, if I start trying to draw tangent lines on a concave up shape, what we'll notice is that all of those tangent lines are actually down below our graph everywhere. So that's the opposite of what we want. We don't want our r of x graph to be below our f of x graph. We wanted it to be above always. And so that's why this one is definitely not true. It's not even possible. So this would be option C. that we were looking at a concave down graph always, because the only time we could guarantee that our tangent line is always above, which is what we had to do, our actual graph, is if we have a concave down graph. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.